Hey, happy Friday, folks. Today what we got for you is collision type number 4. Okay? The major difference now is we are going to see movement in both. Right? So here we go. All right. Like I said previously, we're going to see that both these objects are moving towards each other. So this is your typical head-on collision with each other. Because both objects are now moving, both will have initial momentum. All right. The other thing to be aware of here is that now direction really does matter, right? One of these has to be positive, one of these has to be negative, because you're going to see one of these will cancel out either completely or partially the amount of momentum from the other one there. Okay. So here we go. We've got a 90 kilogram hockey player moving at 5 meters per second, collides head on with a 110 kilogram hockey player moving at 3 meters per second in the opposite direction. How much momentum does the 90 kilogram player have? So what you can see is over on the left here, I've got my data. All right. So I'm going to take and first find the momentum of the 90 kilogram person. So I'm going to take that 90 kilograms times 5 meters per second. I end up finding that the momentum for the 90 kilogram person is 450 kilogram meters per second. Okay? The second one, how much momentum does the 110 kilogram player have? All right. Well, that's the same calculation as we just did. Now, notice the subtle difference here. All right. Let me get a pen. Oh, go back. Right? Notice this. We'll just go with a pen. Notice the -3. Sorry about that, folks. So notice the -3. I chose the second player to be going the opposite or wrong direction, whichever way you want to go. Okay. Yes, it directed that in the actual problem that they were going that negative direction, but in the grand scope of it all, I just chose that one, so to speak. Okay. So this one's going to experience or going to have -330 kilogram meter per second of momentum. Okay. What is momentum after the crash? All right. So, oh shoot, this is supposed to be 90. Sorry, I copied and pasted and did a poor job of it. So my momentum of my 90 kilogram plus the momentum of the 110 kilogram is going to equal the momentum of both of those together. So this is where that negative comes into play. What we end up seeing here is this 450 plus a -330 gives us 120 kilogram meter per second momentum for both of these after the collision, after they stuck together. All right. Now, if you would have made this positive, meaning that you would have left them going both the same direction, then they would have added together and created what, 780, which would have been way too high for this collision, okay, for the resulting momentum of that. That would have meant that one's going that way and the other kind of piggybacks onto them and just rides us back the whole way there. Okay. So, and if this momentum overall is positive or negative, it's okay. It just tells us which way it's going. So if the 110 would have been bigger, guess what? It would have been negative, meaning that it was just going that person's direction. Okay. Lastly, then, how fast did they move off together? So once we know the total momentum, we're able to figure out the velocity based on their mass being together. Okay. So we take that 120 divided by 200. We find that they go from 5 and 3 respectively down to 0.6 meters per second. Now, again, here the direction for that velocity, which way they're traveling, would have been the same direction that the 90 kilometer or 90 kilogram person was traveling. Basically the opposite way of the 110. Okay. That's kind of it for now. Make sure that you're running through and trying these out so that you can be prepped and ready for Monday. That is it. See ya.